So one of the most important things in algebra is factoring. And generally speaking, in mathematics, factoring is quite important because it helps us write things in a nice way and it's quite organized. So what is factoring? So first off, we need to know what a factor is. Suppose we have the number 4. I could write it as a product of multiple individual factors. So those in this case are 2, 2, and 1. So the first 2 is a factor, the second 2 is a factor, and 1 is also a factor. By default, what we have are 2 factors and 1 to be a factor of any number. No matter what number we take, 1 is always a factor of that particular number, which is why we don't like to write it and say, okay, 1 is a factor. People would simply go and write it as we have 4. We'll just write it as 2 times 2 because 1 is a factor by default. So we have to extend this concept to something called the greatest common factor, because if we have multiple terms, then we've got to look for something in common so we can pull that particular term out. What do I mean by that? Suppose we have 3 numbers. Four, 12, and 16. So the objective is to write the bigger numbers in terms of the smaller numbers and break down the smallest number in terms of its factors. What do I mean by that? I know 4 can be written as 2 times 2 times 1. The next bigger number is 12. I have to write 12 in terms of 4. It is possible. So we have 4 times 3 times 1. But 4 can be written in terms of its factors, which is 2 times 2. We'll ignore that 1. So next is 16. So 16, first step, we've got to write it in terms of the smallest number that we see, if it is possible. So we would have 4 times 4. But then we know that 4 has factors 2 times 2. So I could write it as 2 times 2 times 2 times 2. So we have factored every single number. The objective is to find the greatest common factor. Well, let's just see what is in common. The simplest one that we have in common is 2. Every single term has a 2. But 2 is not the greatest common factor. It is a common factor. It just isn't the greatest. So I'm going to pick 2 2's in each of them. So that is in common between all 3 numbers. So that could be the greatest common factor. Now you look at number 12, and the number 16. 12 has a factor of 3. 16 has 2 more 2's. But those aren't in common with 4. So the only thing that we can see as common factors are that 2 times 2. So the greatest common factor in this case is simply 4. Now, another example, let's just take 5, 17, and 31. Say find the greatest common factor. So 5 as a factor of 5 times 1, and 17 times 1. I cannot break 17 down and write it in terms of smaller numbers. And 31 is the same. You have 31 times 1. So the only common factor here is 1, but we don't consider 1 to be the GCF of anything typically. So if I have to write the greatest common factor, I'm going to say that is going to be 1. That is the best I can do, because 1 is what's in common between those 3 numbers. But having a greatest common factor as 1, it's pretty much useless. So what we will say here is that 5, 17, and 31 have no factor in common. We're simply going to take the same process and apply it to variables. And I'll explain the idea in the next page. So we have to find the greatest common factor for b raised 9, b squared, and b raised 5. Now, previously, when we had a number, we simply tried to write the bigger number in terms of the smaller number so that we can find a common factor. Here, we're going to look at the exponents, and we are going to try and write the bigger exponent in terms of the smaller exponent for each of the terms that we see, or each of the monomials that we see. So the smallest here is b squared. B squared is simply b times b, and of course I'm ignoring 1 because 1 is by default a factor of any expression. The next one I have is b raised 5. Now I could write b raised 5 as b squared times b cubed. Properties of exponents: if the bases are identical, we add the powers. The base here is b, and 2 plus 3 is 5. We know b squared is b times b, and I'll leave b cubed as is. The next one is b raised 9. And first step is to write that b raised 9. It's a larger exponent in terms of the smallest one that we see, which is b squared. So I could write it as b squared times b raised 7. And b squared is simply b times b multiplied by b raised 7. So the common factor here, or the greatest common factor, is b times b, which is b squared, b squared. So the answer here is GCF is b squared. When we have a whole bunch of variables, such as the next one, we're going to extend the same idea that we used in the previous problem. But we try to write the higher exponent for each variable in terms of the lower exponent of the corresponding variable. In other words, we take care of the x squareds, or treat the x squares, treat the y terms, treat the z terms, the same way I did in the previous problem. So let's start with x, y squared, and z cubed. If you look at the three terms, the smallest exponent for x is 1. So we have simply x. And if you compare the three terms, the smallest exponent of y is y squared. So I'm going to leave that as is. And if I look at the three terms in terms of the z terms, the smallest exponent that is in common is 0. The reason being we have z cubed, z squared, there is no z term there. In other words, all we have is 1. So we simply write it as z cubed. Now, moving on to the second term, x squared, y squared, z squared. X squared, 2 is a higher exponent compared to x. So I would simply write it as x times x. The exponent of y squared here and the previous term are one and the same, so I'm going to leave it as is. And z squared is actually a smaller exponent, or has a smaller exponent compared to z cubed, so I'm just going to leave it as z squared. I can go back and rewrite the z cubed as z squared times z, even though it is not going to make a difference in this problem, because z is not common in all three terms. And lastly, we have x squared, y cubed. I know the smaller exponents for the term x and y, the variable x and y, are x and y squared. So I'm going to write the x squared as x times x. I'm going to write the y cubed in terms of the least exponent for y, which is y squared times y. Now we have to look for common factors, the greatest common factors for each of the variables. You look at the x terms, I see x squared in common in the last two expressions, but only x is in common in the first one. So the greatest common factor is simply x for the x terms. For the y terms, I have y squared, y squared, y squared in common, and it is the greatest. I can't simply say y is a common factor because I have y squared, which is bigger than y in terms of the exponents. And lastly, you may say, well, I've got to put the z squared term or the z term. Also, we cannot do that because the first two expressions have z squared in them, but the last one doesn't even have a z term. So the only things that we've found in common are x and y squared. So the greatest common factor is x, y squared. In this problem, we are simply combining the idea of having variables and numbers, put them all together, same process, and we're going to try and get an answer. So first, look at the numbers. We have 4, we have 16, we have 8. The smallest of the three numbers is 4. So if we have to find the common factor, our objective is to write 16 in terms of 4, write 8 in terms of 4, because 4 is the lowest number. Then we look at the x terms. The x terms have the biggest exponent is 2 and the smallest one is 1. So we would want to write x squared in terms of x. And for the y variable, the smallest exponent that we see is y squared. So we have 4, smallest exponent is x, y squared, the smallest exponent for the y variable is y squared. 16xy cubed. I would like to write 16 in terms of the smaller number, which in this case is 4. Could write it as 4 times 4 and x. Y cubed, 3 is a bigger exponent compared to 2, so I could write y cubed as y squared times y. And lastly, we have 8x squared y squared. 8 can be written in terms of 4, so we have 4 times 2 multiplied by x times x, because the lowest exponent for the x term is 1, multiplied by y squared. Now I have to go and hunt for the common term or the common factor in each of the expression. So with respect to the numbers, I have only a 4 in common, and that is the biggest factor that is in common. With respect to the x's, I have x, x, and x in common, and that is the biggest factor that we have in common. And lastly, with respect to the y's, we have y squared in common, and that is the greatest factor that we can see in common. So the greatest common factor here would be 4 times x times y squared. Again, just to remind you, if we're simply comparing numbers like 4, 16, and 8, we try to write the bigger number in terms of its smaller factors. But if you're dealing with terms such as x, y squared, and so forth, we're going to look at the exponents and try to write the bigger exponent in terms of the smaller exponent corresponding to each variable. So we can start with the first term, which is 12y squared z raised to the power of 4. And the numbers here are 12, 9, and 15. So we want to write 12 in terms of 9, which is not possible, but we can write 12 in terms of the factors of 9, which should be 3. So let me start with the second expression and write 9 as 3 times 3. X is by itself. Then I look at the other two terms and I see y squared, and y has a bigger exponent here, so I could write it as y squared times y. Likewise, when I look at all three terms, z cubed is the smallest exponent, so I could write z raised 4 as z cubed times z. Now that I've sorted this, I could go back and rewrite the other terms. So I've realized, okay, the smallest factor has to be 3 for 12. So 3 times 4 is 12. And y squared is the smallest, it's the greatest common factor. And z raised 4, I have a z cubed in one of the three expressions, so I could write it as z cubed times z. Likewise, 15, I could write it as 3 times 5. The smallest exponent for x, the x term or x variable, seems to be x. So I'm just going to write the x squared as x times x, and y squared multiplied by z cubed. Now we start comparing and hunt for the common factor. In terms of the numbers, 3 is common amongst those 3 expressions. In terms of the x variable, one of the terms doesn't even have an x. So clearly, x cannot be a common factor. So we switch on and look for common factors in terms of y. So I have y squared, y squared, y squared, that is in common. And in terms of the z term, I have z cubed, z cubed, z cubed, and z cubed in common. So the other terms, they're not in common, and we've already sorted out the greatest common factor. So the answer here is 3 multiplied by y squared multiplied by z cubed. So in these problems, our objective is to take this expression, pull the common factor out, and write it in a simplified form. In other words, we are going to write it term by term or factor by factor so that the expression looks nice. So where to start? To start, we are going to look at the terms of this binomial expression as individual monomials. So 4y squared and 16xy cubed. Of the two, 4 is a common factor. So 16 can be written as 4 times 4x. And for the y term, y squared has the least exponent. So I could write y cubed as y squared multiplied by y. And in the first one, we have 4 times y squared. Now we look for common factors between the two. So I have 4 in common and y squared in common, and that's it. So the GCF is simply 4y squared. Now, how does this help in terms of simplifying? I'm going to rewrite the expression. The first one is 4y squared. Great. If we go back and look at 16xy cubed, I broke it down and I wrote it in terms of the GCF and whatever that was left behind. So one of them is 4y squared, that's the GCF. The part that wasn't in common was 4xy. Now, that term and that term are in common between the first monomial and the second monomial. So I can pull that out. So if I pull 4y squared out of the first term, I should leave behind 1, or I will be leaving behind 1. If I pull 4y squared out of the second term, I'll simply be left with 4xy. So this expression is the simplified version of the original one because we have it nicely written in a factored form. Now we have a trinomial, but the process is nothing different. Treat or consider each monomial for each individual term, and let us look for the smallest number that we can recognize between 6, 8, and 2. That would be 2. For the x terms, the smallest exponent is 3, so I'll have x cubed I can rewrite that 6 as 2 times 3. I could rewrite that x raised 5 as x cubed times x squared. I could rewrite 8 as 2 times 4. And x raised 4 as x cubed times x. The reason being the common factor here would end up being x cubed. So in terms of the numbers, we have 2 in common. For the x terms, we have x cubed in common. So the greatest common factor is 2x cubed. So 6x raised 5, I can now write it as 2x cubed multiplied by 3x squared. 8x raised 4, I could write it as 2x cubed multiplied by 4x. And lastly, I have 2x cubed by itself. We already know that the GCF is the common term that we have amongst those 3 terms. So I am going to pull that out from each of those 3 terms. So if I take out 2x raised 3 from the first term, I will have 3x squared. If I take out 2x cubed from the second term, I'll have negative 4x. And if I take out 2x cubed from the last term, I'll have 1, because every number has 1 as a factor.
Wait, do you want the where you put?
So the first thing that we should do here is to write out the individual terms. Keep in mind, once you have a lot of practice, you don't have to do it the way we're doing it. People would start recognizing it right away. So I'm going to look at the numbers, and it looks like the smallest number is 4. So I'm going to write 8 in terms of 4. I could write it as 4 times 2. Then I'll look at the exponents for a. The smallest exponent that I see is 1 for a. So I'm going to write a cubed as a squared multiplied by a. Then I look at the exponents for b. The least exponent that I see is just b. So I'm going to try and rewrite b cubed as b squared times b. We'll do the same. 4 is 4 by itself. The smallest exponent for a is just a as is. So I'm going to split up a squared and write it as a times a. The smallest exponent for b is 1. So I'm going to rewrite b squared as b times b. There is nothing to factor in the third term. I'll leave that as is. And lastly, I would like to write 16 in terms of its smallest factor, which should be 4. The smallest factor that is common amongst all those terms, multiplied by a. Since the least exponent for b is just b by itself, or 1, I'm going to split it up and write it as b times b. Now we look for common terms. So 4 is in common. A is in common for the variable a. And b is in common for the variable b. So the greatest common factor is 4ab. Now, if I take away 4ab from each of those terms, you just have to look at what you leave behind. For instance, in 8a cubed b cubed, if I pull 4ab out, I'm left with 2a squared b squared. The sign is negative, so negative. In the second term, if I take out 4ab, I'm leaving behind a and b. In the third term, if I take out 4ab, I'm going to leave behind 1, because 1 is a factor of every expression. And lastly, if I take out 4ab, I'm going to leave behind 4b. And it is conventional to put the constant at the very end, so I'm going to write it as 4ab, 2a squared b squared minus ab plus 4b plus 1. So the next example is one of the key concepts that you cannot forget, especially if you plan on pursuing college algebra or calculus or one of those. It's called factoring. We're going to do more problems on this later, but just by looking at it, there is a common factor between the first and the second term. So I'm going to write it as 6 times x plus 3 plus 5a times x plus 3. In the first term, I see x plus 3. The same term is repeated in the second. So I have x plus 3 in common, so the greatest common factor is actually x plus 3. And if I pull x plus 3 out, you can either use square brackets or parentheses, use whichever one that would result in the least amount of confusion. So if x plus 3 comes out, you're left with 6 in the first term. If x plus 3 is taken out of the second part, you have only 5a left behind. So that is the factored and simplified version of the given expression. So just by looking at this problem, we have 9x multiplied by y minus 2 plus y minus 2. We have y minus 2 in common, so the GCF is y minus 2. And if I pull out y minus 2 from the first term, I would leave behind 9x. If I pull it out from the second term, I'm going to leave behind 1. So the first one that we see is quite straightforward. The common factor is 2x squared plus 3. It's in both terms. So if we pull, 2y squared plus 3. And if we pull that out, we will leave behind 4x in the first term and minus in the middle and 5. So now we took that expression and wrote it in a very factored way, in an organized way. The second one here, we have 12b raised 4, 3b squared, and 1. 1 is just 1. There's nothing we could do about that. Now 12, we want to write it in terms of the smallest number that is not 1. I could write 12 as 4 times 3. And the smallest exponent in b that we see is b squared. So I'm going to write b raised 4 as b squared multiplied by b squared. So the second term would simply be 3b squared. And if I look at those individual monomials and I don't see anything in common, the only factor that is common amongst those 3 terms is 1. So the greatest common factor is 1. And if I pull 1 out from each of those terms, I am still left with 12b raised 4 minus 3b squared plus 1, because I'm pulling out just 1. So 12b raised 4 minus 3b squared plus 1 multiplied by 1 is still the same answer. So in conclusion, that particular expression cannot be simplified further. So we have two terms here, 38x squared, y raised 4, 57x, y raised 4. And we want to look for a factor that is common between 38 and 57. Now, earlier today, I gave you the idea that we want to write the bigger number in terms of the smaller number. So naturally, you would wonder and say, oh, I'll try to write 57 in terms of 38, but that's not feasible. So that doesn't mean you should just abandon and leave it as is. Think of a different number that is common to both 38 as well as 57. And that number is 19. So 19 times 2 is 38. 19 times 3 is 57. Now we look at the x terms. The least exponent is 1. So I'm going to write x squared as x times x. And y raised 4 is common in both of them, so I'll just keep it as y raised 4. So what is in common between the two terms? In terms of the numbers, we have 19 in common. For the x's, we have x in common. For the y's, we have y raised 4 in common. So the greatest common factor is 19x y raised 4. Now we have to pull that greatest common factor out, 19x y raised 4. If it comes out, well, what do we leave behind in the first term? We go back and look over there. 19x y raised 4 comes out, leaving behind 2x. In the second term, if I pull out 19x y raised 4, I will leave behind 3. There is a minus in the middle. So that would be the simplified or factored version of the given expression. So the last topic here is the concept of grouping. Grouping is done first by gathering terms so that we sort of write it in this form, which was easy, because the moment I have it written in this form, then I can immediately recognize, hey, the GCF is y minus 2. I'll just pull it out. That's exactly what we're trying to do in grouping. So take the first two terms, AB plus 3A, and the last two terms, 2B plus 6. So I'll put a bracket here, bracket there. So I could write AB as A times B. I could write 3A as 3 times A. That's the best I can do. So what is common in or among these two terms? And A isn't common. So for that expression, the GCF is A. Now we can move on to the second expression, which is right over here. And there are two terms. We have 2b, and the factors are simply 2 and b. 6 is the bigger number, and I can write it in terms of 2. So 6 can be written as 2 times 3. So the GCF for those two terms would simply be 2. So if I pull a out from the expression shaded in pink, I'll have a outside the square bracket. What would I leave behind? I am going to leave behind b, and I am going to leave behind 3. Now we move on to the teal one. The GCF is 2, so if I pull 2 out, I am going to leave behind b, and I am going to leave behind 3. But we're not done yet, because this is one of the previous cases where we have another common factor, b plus 3. So if I pull b plus 3 out of each term, b plus 3 comes out of the first term, I'd leave behind a. If I pull b plus 3 out of the second term, I am going to leave behind 2. So the simplified version of the polynomial is actually b plus 3 times a plus 2. So the key here is we have a negative hanging in there. So the first two terms, I am going to write it as b times c plus 8b. And since I see a negative in both of those terms, I'm going to pull that negative out. That would leave me with 3c plus 24. It is always good practice when you have a negative, it's better to pull the negative out, or else, you know, you are trying to put yourself in a weird position. So we look at the first two terms here. The terms are bc and 8b. I could write bc as b times c, 8b as 8 times b. And there is only one factor that is in common, but that would be b. And I move on to the second term over there. I have 3c plus 24. 3 is the smaller number, so I could write 24 as 3 times 8. And I know what's in common now. 3 is in common. So let's go back to the first expression that is shaded in blue, light blue. The common factor is b. So if I pull b out, I'm going to leave behind c. And if I pull b out from the second term, 8b, I'm going to leave behind 8. Minus, if I pull 3 out, I'm going to leave behind c. And if I pull 3 out, I'm going to leave behind 8. So we will have b minus 3. Oh, sorry, I don't want to skip a step. Now you have to recognize that c plus 8 is in common between those two terms. b times c plus 8 minus 3 times c plus 8. So if I pull c plus 8 out from the first one, I'm going to leave behind b. And if I pull c plus 8 out from the second term, I would leave behind 3. So the factored and simplified version would be c plus 8 multiplied by b minus 3. So since I see a negative, when we group things, it's best to have that negative isolated. What do I mean by that? So that's the first term. I'm going to pull the negative out and write it as 4y because I pulled a negative out. I'm taking a negative from a positive sign, so there should be a -3 there as well. There are two terms. The first one is 20xy. The other is 15x. Certainly we can't write 15 or the bigger number 20 in terms of 15, but the common factor is 5 here. So I could write it as 4 times 5 times x times y. And 15, I could write it as 3 times 5 times x. The second part, we have 4y and 3. And there is nothing in common between 4y and 3 except 1. And over here, the common factor would be 5x, or greatest common factor. So in the first two terms, if I pull out 5x, I am left but with 4y and 20xy and -3. Because if I take 5x out of 15x, there is a minus in the middle, and I've got 3. So minus, we have 4y minus 3. The confusion happens oftentimes because you don't see a number there. That's where this tiny bit needs to come into play. Now, what is common between those two terms? It's just 1. So there is a 1 in front of 4y minus 3. If you recognize that part, I would simply have minus 1 times 4y minus 3. Now you can see that 4y minus 3 is in common between those two terms. So if we pull that out, if I take 4y minus 3 out of the first expression, I have 5x. If I take 4y minus 3 out of the second expression, I have -1. And that would be the final answer. If you recall, a trinomial has 3 terms. For example, x squared plus 9x plus 16. And this is the same as saying 1 times x squared plus 9x plus 16. The 1, 9, 16, they're all coefficients of the polynomials. So there is a key trick to factoring a trinomial. So if I wrote the previous example, I could simply say 1 to be the first coefficient, second coefficient, and the third coefficient. So, or call it last. And this particular process is sort of as trial and error. In other words, you've got to know the two steps that I'm about to write. First, you pick two numbers. I'll say easy numbers, numbers that you can work with easily. And the sum of the two numbers must equal the middle or the second coefficient. The product of the two numbers the product of the two numbers must equal the product of the first and last coefficient. And a word of caution, this is pretty much a trial and error based approach. So we want to factor this trinomial x squared plus 9x plus 18. So the first coefficient is 1, the middle is 9, the last is 18. So the product of the first and last coefficients is 1 times 18, which is 18. The sum must equal 9, which is the middle coefficient. So we've got to come up with two numbers, which when I add, I get 9, and which when I multiply, I get 18. Well, you have to be very reasonable when you pick these numbers. I know what those two numbers are the moment I see this. If I add two numbers, I need to get 9. There are a few possibilities. You could say, oh, let me pick 5 and 4. Well, 5 and 4, if you add, you would get 9, but when you multiply, you're not going to get 18. You may say, oh, how about 7 and 2? Well, when you add, you get 9, but when you multiply, you're not going to get 18. So if you go back and forth this trial and error approach, you would eventually realize, okay, how about 6 and 3? When I add 6 and 3, I get 9. When I multiply, I am going to get 18. So that is the correct factoring approach. Now, we just have to split this up, write it as x squared, distribute the x, 6x, plus 3x, plus 18. Now we can factor by grouping. We have to look for a common factor between x squared and 6x. So the common factor, the greatest common factor between x squared and 6x is x. So if I take out x from the first two terms, I would leave behind x and 6. There is a plus sign in the middle, so plus. I look at the last two terms. 3 is in common between the two terms. So if I take out 3, I am going to leave behind x. and take 3 out of 18, we'll get 6. So the x and the 3 that are in red are simply the greatest common factors of the first 2 terms and the last 2 terms. Now that we've grouped it and written it this way, we could see that that part and that part are the same. So that is a common factor. We're going to do what we did in the previous video and pull that x plus 6 out. If I pull x plus 6 out of the first term, I would have x. If I pick x plus 6 out of the second term, I would have 3. So x plus 6 times x plus 3 would be the factored version. You could always FOIL this, and if you FOIL this, you will get x squared plus 9x plus 18. So here we have one with a negative sign. So we have negative 12, and there is positive 27. So when we multiply 2 easy numbers that I pick, I must get the product of 1 and 27. It is the product of the first and last coefficients. The sum of the 2 easy numbers must equal negative 12. So what should the numbers be? Well, you can either look at that negative as is. It's better to keep that negative. Ignoring that would actually result in problems. But can you multiply a positive and a negative number and end up getting a positive number? It is impossible. So the numbers that I'm going to pick, both of them either have to be positive or both of them must be negative. Now, I have 27 and I know certain factors for 27. So I could have 9 and 3. So I could either have minus 9 minus 3, minus 9 plus 3, positive 9 minus 3, and positive 9 positive 3. Let's go backwards. If I add these easy numbers, I am not going to get negative 12. So that's not going to work. The easy numbers are 9 and negative 3. If I add those two, I am not going to get negative 12. That goes. If I add minus 9 and 3, I am not going to get negative 12. So that's not correct. Negative 9, negative 3 seems to be negative 12, or it is negative 12. But we can't jump to the conclusion yet. You have to see whether the multiplication of negative 9 and negative 3 would result in 27. It certainly does. Minus 9 times minus 3 is positive 27. So the two easy numbers, they have to be minus 9 and minus 3. So since it is a sum, I could write it as negative 9, negative 3, or you could say negative 9 plus 3. They are one and the same because I'm simply distributing the negative inside. So going back to my equation, I have x squared minus 12. I'm going to write it as negative 9 plus 3x. That's exactly what I have here. And 27. I can distribute the x like I did previously. X squared minus 9x minus 3x plus 27. Now I have to group terms. So x squared minus 9x would be the first group. Since I see a negative, it's best to pull that negative out and write the other group as 3x minus 27. Some are perfectly fine with having it as positive and trying to solve the problem. If you're comfortable with that approach, go for it. Now I have two group terms. In the first one, the common factor between x squared and 9x is x. If I pull x out, I'm going to leave behind x for x squared. I'm taking x out of 9x. There is a minus in the middle, so I have x minus 9. In this last two terms, I have 3 and I have 27. The only thing that's common between those two numbers is 3. So if I pull 3 out, 3 comes out of 3x, so I'm going to leave behind x. 3 comes out of that 27, so I'm going to leave behind 9. But there is a minus in the middle, so I left that minus as is. Now you could realize that x minus 9 is common to the first two terms, the grouped terms. So if I pull x minus 9 out of the first term, I'm going to leave behind x. There is a minus in the middle. If I pull x minus 9 out of the second group term, I'm going to leave behind 3. So the factored version of the polynomial is x minus 9 times x minus 3. So we have x squared minus 2x minus 24. I've got to come up with two numbers so that when I add them, I get minus 2, but when I multiply them, I should get minus 24. Why? The first coefficient is 1, the last one is negative 24. So the product of the two easy numbers that we're going to pick must equal to 1 multiplied by the last coefficient, negative 24. So I need negative 24. The sum of the easy numbers must equal negative 2. So what are the numbers that could produce 24 as a product? 8 times 3 does, 12 times 2 does, 6 times 4 does. But if you think about it, if I picked 8 and 3, if I said negative 8 and 3, when I add them, I'm not going to get negative 2. But if I picked negative 6 and positive 4, then when I add them, I will get negative 2. And the product of negative 6 and 4 is negative 24. So the two numbers have to be negative 6 and positive 4. So I'm going to write that negative 2 as negative 6, positive 4x, and minus 24, which would give me x squared, distribute the x, minus 6x, plus 4x, minus 24. Now I've grouped those two terms and those two terms. I simply have to pull the common factor out. Among those two, the greatest common factor is simply x. If I pull x out of x squared, I'll simply have x left behind. X out of 6x, I would have minus 6. In the last two terms, 4 is in common. So if I pull 4 out of 4x, I would leave x behind. 4 out of negative 24 leave us with negative 6 behind. Now, if you look at those two terms, x minus 6 is in common. So if we pull x minus 6 out, we will have x in the first term. There is a plus in the middle, plus 4. And that would be the factored version.